Hi, Mr. Wright here, and welcome to this set of IGCSE exam questions, which are about grades 6 to 8. So these sets of questions are perfect if you're approaching your exams and you want to practice questions on a range of topics, all at a certain level. So hit the link in the description, download the questions, have a go, and then watch my worked solutions. If you find this film useful, please hit like, and if you have any questions, of course, leave them in the comments and I'll respond. Good luck. Question 1. I need to write this expression as a single fraction. I see I've got a subtraction and a division, so I'm going to do the division first. So I've got 5 minus, right, put this in a brick bracket, got x plus 2 over 1 multiplied by x minus 3 over x squared minus 4. Well, that's the difference of two squares, x plus 2, x minus 2. Okay, so I've got 5 subtract. Right, what's going to happen in these brackets here? Well, I can cancel, divide top and bottom by x plus 2. So that leaves me with x minus 3 over x minus 2. Okay, all right, so I've got 5 over 1. I'm going to write them both over x minus 2. So I'm going to have 5 lots of x minus 2 over x minus 2 minus x minus 3 over x minus 2. Best put that in brackets and just be quite careful because I've got a minus outside the bracket there. So that's going to give me 5 lots of x minus 2 minus x minus 3 all over x minus 2. Multiply out that bracket, 5x minus 10 minus x plus 3 over x minus 2 will give me 4x minus 7 over x minus 2. I can't factorize the top, I can't factorize the bottom, so that must be my final answer. 4x minus 7 over x minus 2. Question 2. I've got a cylinder and a sphere. The cylinder has radius r and height h. The sphere has radius of 2r. The volume of the cylinder is equal to the volume of the sphere. Find an expression for h in terms of r. Give your answer in its simplest form. Right, let's have a look. Well, the volume of the cylinder, which is given by this formula, pi r squared h, that's the volume of the cylinder, is equal to the volume of a sphere. Well, here's the formula for the volume of a sphere. Okay, so presumably I can simply substitute in what I know. Let's have a look. Well, the volume of the cylinder has got a radius of r and a height of h, so that's going to remain as is. The volume of the sphere has got a radius of 2r, hasn't it? So pi times 2r cubed. Make sure you cube that 2 as well. Right, divide both sides by pi, so I forget about those. So I've got r squared h here, and I've got 4/3, the pi's gone, times 2, that's 8r cubed. Okay, now what's the answer? The question is asked me to find the expression for h in terms of r, so h needs to be the subject. But I need to give my answer in as simple terms as possible, so let's start by simplifying this, shall we? 8 4s are 32. 32 over 3 times by r cubed. Now I'm going to divide both sides by r squared. It's going to give me 32 over 3r. And that looks to me to be an expression for h in terms of r in its simplest terms. So my answer is that h is 32r over 3. That's my answer for that question. Question 3. Factorize this expression. Well, that is the difference of two squares. 2x plus 1, lots of 2x minus 1. I assume that that's the answer for section A is going to help me in section B. Let's have a look. Solve that equation. Okay, well, let's start off by rewriting it using what we've just worked out in section A. Factorize the denominator there of that fraction. Okay, right. Well, you can do this in several ways. I'm going to add the two fractions on the left-hand side. So I'm going to have 4 lots of 2x minus 1 over 2x plus 1, 2x minus 1 plus 1 over 2x plus 1, 2x minus 1 equals 3. So that gives me the top, which is 8x minus 4 plus 1, all over 2x plus 1, 2x minus 1 equals 3. I'm going to multiply. No, I'm not. I'm going to simplify the denominator here. 8x plus 3 over 2x plus 1, 2x minus 1. I was kind of thinking that perhaps I could factorize the top and do some cancelling, but I don't think I can. So now I'm going to resort to multiplying top and bottom by the denominator of that fraction. So I'm going to have 8x minus 3 equals 3 lots of 2x minus 1, sorry, 2x plus 1, lots of 2x minus 1. Which is going to give me 8x minus 3 equals 3 lots of 4x squared minus 1, which is going to give me 8x minus 3 equals 12x squared minus 3. I'm going to take my 8x minus 3 onto the other side here, because I've got a quadratic equation, so I'm going to set it equals 0. If I plus 3 to both sides, then the constant term disappears. Now I'm going to look to factorize the left-hand side. So that's 4x can come out there, leaving me with 3x minus 2 equals 0. So my two solutions are either drawn out at x equals 0 or x equals 2/3. So there we go. There's my solution to question 3. The diagram shows a straight line with equation y equals kx intersecting this curve. At that point, you've got to find the coordinates of the point of intersection, giving your answer in its simplest form in terms of k and n. Right, well, where the two lines cross will satisfy this equation, won't it? N over x equals kx, multiply through by x, and now make x the subject of that equation. Obviously, we're only interested in the positive square root here because x is a positive solution. So there's an expression for the x coordinate. Now, so the y coordinate will be k times x, which will be k times the square root of n over k. Now, there's some simplification we can do here. I'm going to take the 1 over k out of the square root. So that's going to be k over root k times root n, which is root k times root n, which is root kn. So my x coordinate and my y coordinate are as follows. P is my x coordinate, so p will be the square root of n over k, and q is the y coordinate of the point of intersection, which will be root nk. Good. All right, so there's my answers there. Given that P equals 2Q, right, so P, which is root n over k, equals twice Q. Find the value of k, right, well, I'll square both sides. N over k equals 4nk. Multiply through by k will give me n equals 4nk squared. Right, divide all the way through by n will give me 1 equals 4k squared, which gives me k squared is a quarter, so k could be plus or minus a half. Looking at the diagram, k is positive, isn't it? Because the line y equals kx has a positive gradient, so k must equal 1/2. And there is my solution for question 4. Question 5. Solve this quadratic equation showing you're working clearly, giving your solutions correct to 3 significant figures. Right, so clearly I'm going to need to use the formula here. A will be 1, B will be minus 4, C will be minus 1. So x equals minus b plus or minus the square root of b squared, which is minus 4 squared minus 4 times 1 times minus 1 all over 2 times 1 is 2. Right, so that gives me 4 plus or minus the square root of 16 plus 4 is 20. Okay, so now I'm going to use my calculator to give me my 2 solutions. 4 plus the square root of 20 equals, divided by 2 equals 4.23. What am I doing? 3 significant figures, so 4.24 or 4 minus root 20 equals, divided by 2 equals 0 minus 0.3 significant figures here, 2, 3, 6. There we go, right. Hence or otherwise, so probably hence, solve this equation. Well, if I look at the equation that they're asking me to solve, this one here, it looks identical to the one in section A, except that question A's x is equal to x plus 3 here. So presumably my solutions would be x plus 3 would be 4.24, or x plus 3 would be minus 0.236. So in this case, x would be minus 3 from both sides, 1.24, and minus 3 from both sides here as well, minus 3.236. So there are my solutions to question 5. Just a moment. Give this one to 3 significant figures, minus 3.24. There we go.